Open your fridge right now, in your mind, and picture what's inside. Neat packages, labeled portions, food that traveled hundreds, maybe thousands of miles to get there. You didn't hunt it. You didn't forage for it. Someone else grew it, and someone else shipped it, and all you had to do was choose it off a shelf. But for almost the entire span of human existence, none of that infrastructure existed. So what did people actually eat every single day before farming gave us this convenience? The honest answer is stranger, messier, and far more resourceful than most people imagine. For a long time, the popular image was simple. Cavemen eating meat around a fire, full stop. That image is comforting because it's simple, but it's also almost completely wrong. Anthropologist Katherine Milton spent years comparing the diets of wild primates to early human ancestors, and her research pointed to something surprising. Early hominins likely ate an enormous variety of plant foods, not as a side dish, but as the backbone of daily survival. Roots, tubers, wild fruits, nuts, leafy greens. Insects too, often overlooked, but a genuinely significant source of protein and fat in many hunter-gatherer diets even today. Consider termites for a moment. In several documented hunter-gatherer societies, termite mounds represent a dependable, calorie-dense food source, available across much of the year, requiring only patience and a simple digging tool to access. Grubs, larvae, and certain caterpillars show up again and again in ethnographic accounts of foraging behavior, not as an emergency backup food, but as a genuinely routine part of the weekly diet. It doesn't fit the dramatic imagery of ancient life, but it's far closer to how most days actually unfolded. Why does this matter? Because meat, while valuable, was never guaranteed. Hunting large animals is difficult. It requires tools, coordination, and often sheer luck. A missed hunt could mean days without meat. Plants, by contrast, don't run away. They don't fight back. They're slower to acquire in bulk, but far more reliable. And that reliability likely shaped the actual rhythm of the ancient diet far more than dramatic mammoth hunting scenes ever could. Here's a question worth sitting with for a moment. If plants were so central, why does meat get all the cultural spotlight? Part of the answer lies in a discovery made by primatologist Richard Wrangham. Wrangham proposed something now known as the cooking hypothesis, the idea that controlled use of fire didn't just make food taste better, it fundamentally transformed human biology. Cooked food is dramatically easier to digest than raw food. Cooking breaks down tough plant fibers and unlocks calories that would otherwise pass through the body largely unused. According to Wrangham's research, this shift may have freed up enormous amounts of energy that could then be redirected toward fueling something metabolically expensive, a larger, more complex brain. Think about that for a second. The moment early humans learned to control fire wasn't just a lifestyle upgrade. It may have been one of the single most important turning points in the evolution of human intelligence itself. But cooking didn't erase the plant-heavy foundation of the ancient diet. It expanded it. Roasted roots, charred tubers, nuts cracked open and lightly toasted. Suddenly, foods that were previously difficult to digest or even mildly toxic in their raw form became safe, nutrient-dense staples. So what did an actual day of eating look like tens of thousands of years ago? Researcher Amanda Henry took a remarkably direct approach to answering this question. She studied dental calculus, the hardened plaque preserved on ancient teeth, extracting microscopic starch grains trapped inside it for thousands of years. Her findings, examining remains associated with both Neanderthals and early modern humans, revealed starch grains from a wide variety of plants, including some that had clearly been cooked before being eaten. This wasn't guesswork or assumption. This was direct physical evidence, pulled straight from ancient teeth, confirming that plant foods, prepared with heat, were a real and recurring part of the diet. This detail quietly demolishes another popular myth, that Neanderthals were purely brutish meat eaters, disconnected from any kind of dietary sophistication. The calculus tells a different story, a more resourceful one where survival depended on knowing which plants were edible which needed cooking to become safe, and which seasons produced which foods, all tracked and remembered without a single written record to rely on. Archaeologist Curtis Marion, studying ancient coastal cave sites in South Africa, found early evidence that some populations were harvesting shellfish in large quantities tens of thousands of years ago, well before farming existed anywhere on Earth. Shellfish beds don't run away, and they don't require elaborate tools or coordinated group hunting, just knowledge of the tides and the patience to work the shoreline at the right moment. For communities living near the coast, that steady, low-risk food source may have provided exactly the kind of dietary stability that inland foraging couldn't always guarantee, and the diet wasn't static either. It shifted constantly with geography and season. Communities near coastlines relied heavily on shellfish, fish, and seaweed, a diet rich in the kind of fatty acids linked to brain development. Communities in grassland environments leaned more heavily on roots, seeds, and, when possible, hunted game. Communities in forested regions gathered nuts, fruits, and insects in far greater quantities than most modern diagrams of caveman meals ever suggest. This variability had a real cost, though. Food security in the modern sense simply didn't exist. A poor season for foraging, a failed hunt, a sudden shift in migration patterns among prey animals, any of these could mean real hunger. Early humans weren't lounging around campfires with abundant guaranteed meals. They were constantly adapting, constantly reassessing what was available, constantly making calculated trade-offs between effort and payoff. Here's the twist that reframes the whole picture, though. Despite this uncertainty, despite the physical demands of foraging and hunting, skeletal evidence from many hunter-gatherer populations actually shows fewer signs of chronic malnutrition compared to some early farming communities that came later. When agriculture emerged, diets often became less varied, more dependent on a small handful of staple crops, like wheat, rice, or maize, grown in large quantities but lacking the broad nutritional range that foraging naturally provided. In other words, the shift to farming, often framed as pure progress, came with real biological trade-offs. More reliable food quantity in many cases, but often at the cost of dietary diversity. Modern research on surviving hunter-gatherer communities adds even more texture to this picture. Anthropologist Herman Ponzer spent years studying the Hadza people of Tanzania, one of the last populations on Earth still relying heavily on foraging and hunting for daily survival. His measurements of their actual daily energy expenditure produced a genuinely surprising result. Despite walking long distances and performing physically demanding work almost every day, the Hadza burned roughly the same total daily calories as sedentary people living in modern industrialized countries. Their bodies, it turns out, quietly compensate, adjusting other internal processes to keep total energy use remarkably stable, regardless of activity level. This finding reshapes a common assumption. It's not that ancient humans burned dramatically more calories through constant movement. It's that their bodies use that same fixed energy budget completely differently, funneling less toward the kind of chronic low-grade inflammation and metabolic strain that shows up so often in sedentary modern lifestyles. There's another layer to this story, hidden somewhere researchers didn't expect to find it, inside the gut itself. Microbiologist Stephanie Schnorr examined the gut bacteria of the Hadza and found a strikingly different microbial community compared to populations eating typical Western diets, one shaped almost entirely by extreme dietary variety and heavy fiber intake. Their gut environments shifted noticeably with the seasons, expanding and adapting depending on which plants, tubers, or animal foods were available at any given time of year. A modern gut, by comparison, often settles into a much narrower, more static microbial pattern, shaped by a diet that barely changes from week to week. This raises an uncomfortable but genuinely interesting question. Did agriculture actually make human diets better, or did it just make food more predictable? The honest answer researchers tend to land on is, both things were true, but not equally, and not everywhere. Predictability mattered enormously for population growth and the eventual rise of permanent settlements. But nutritional diversity, the kind woven naturally into a forager's daily life, was something many early farming societies had to slowly rebuild over generations, often without fully realizing what had been lost. So what does any of this actually mean for you? Sitting here today with a fully stocked fridge and more food variety within arm's reach than most ancient humans saw across an entire year, your body, in a very real sense, is still tuned to that ancient rhythm. Your digestive system evolved around irregular abundance and scarcity, around bursts of fat and protein followed by long stretches of plant-heavy, fiber-rich foraging. Modern diets, dominated by processed, calorie-dense, low-effort food, exist in almost complete contrast to the conditions your biology actually adapted for. That mismatch, many researchers argue, sits quietly behind a surprising number of modern health struggles, not because ancient humans ate perfectly, but because their diets were forced by circumstance into a level of variety and physical effort that modern convenience has almost entirely erased. There's something worth appreciating in this history too. Every single food choice you make today, however small, sits at the end of an extraordinarily long chain of trial, error, and hard-won knowledge. Which roots were safe, which berries would make you violently ill, which plants needed fire before they could be eaten at all. None of that knowledge came for free. It was built slowly, tested against real consequences, and passed down without the benefit of writing, refrigeration, or grocery store labels to rely on. Even something as small as craving something sweet or salty traces back to this same ancient logic. In a foraging environment, sugar reliably signaled ripe, energy-dense fruit, worth prioritizing when it was available, because it wasn't always available. Salt was often scarce and biologically essential, worth actively seeking out rather than passively consuming. Your brain's reward system evolved around genuine scarcity. It has no built-in mechanism for recognizing that abundance, the kind sitting in your kitchen cabinet right now, isn't going anywhere. That ancient wiring hasn't caught up to modern shelves stocked floor to ceiling with exactly the foods it once had to work hard to find. So the next time you open your fridge, take a moment before you reach for anything. Somewhere in the deep background of that simple decision is a 100,000-year-old story of scarcity, adaptation, and quiet resourcefulness, one your body still remembers, even if you've never had to think about it once.